Module 6, problem number 8. Please forgive my voice. I have getting over a little cold, so I'm sorry if you can't understand some of the things. Hopefully it's okay. An engineer wants to determine how the weight of a gas-powered car X affects gas mileage Y. The accompanying data represent the weights of various domestic cars and their miles per gallon in the city for the most recent model year. Complete parts A through D below. Part A, find the least squares regression line treating weight as the explanatory variable and miles per gallon as the response variable. So let's start by clicking on our data set. As you can see here, we have our X column, the explanatory, and the response variable miles per gallon. So let's open that in StatCrunch. As you see here, we have our data set in here. Let's go to Stat, Regression, Simple Linear, select our X variable and our Y variable, and click Compute. Let's make that just a little bit bigger. All right, so as you can see here, we have a couple places we can look at our equation here. We also have the estimate of our slope and intercept here. So I'm going to go ahead and write those down just to make sure we have them. We need 5 decimal places for the slope. So we have y hat equals negative 0.00725 x plus, and you get that right from here, that estimate of your slope, and then plus the intercept. So here in this one we need, I believe, 2 decimal places. Okay, so plus 43.96. See, we have 43.95. We just need to round up to 6. So let's plug those in. We have negative 0.00725 and 43.96. Okay. Interpret the slope and y-intercept if appropriate. Choose the correct answer below and fill in any answer boxes in your choice. I'm going to start off by saying right now, remember with the intercept, we're looking at what would the value of y be if x is equal to 0. In this case, x equal to 0 is a weightless car, which is non-existent. So it's really not appropriate in this case to interpret the y-intercept. So we're going to look at part C. So that eliminates parts A and B. So for part C, we have for every pound added to the weight of the car, that's our X unit, gas mileage in the city will decrease by, and that's where we go to look at our slope. Remember, the interpretation of our slope is for every unit increase of X, what happens to the Y variable? In this case, it's going to decrease. Now that means that we don't need to include the negative with our answer. If it just said it's going to increase a certain amount, then you would say negative. But in this case, it's saying it's already going to decrease some miles per gallon. So in this case, we're just going to put 0.00725. Fantastic. So again, we did not interpret the intercept because a weightless car doesn't exist. So you don't need to do that. And the interpretation of the slope is for every unit increase in X, in this case, like the weight of the car, what happens to the gas mileage? And in this case, it decreases by 0.00725 miles per gallon. Okay, a certain gas-powered car weighs 3,600 pounds and gets 20 miles a gallon. Is the miles per gallon of this car above or below average for cars of this weight? The way we do this is we just plug in that 3,600 pounds into our linear regression equation for X and see what we would expect, or what the Y hat, what we would expect for the gas mileage. Then we compare that to that 20 miles per gallon. So let's go ahead, I just went on the internet and found some very basic graphing calculator. So, or excuse me, scientific calculator here. So just to show you. So first we're going to do negative 0.00725 and multiply it by that weight that it was asking. Remember here, that's the 3,600 right there, and that's at negative 0.00725 right here. So we're going to do that part first, and then once we have that, we're going to add, we're going to do negative 26.1, and we're going to add that second part, that 43.96 from our equation. 33.96. And we end up with 17.86. So we would expect a 3,600 pound car to get about 17.86 miles the gallon. This other car gets 20 miles the gallon. Is that above or below? That's above 17. So we would say it's above average for that weight of car. Lastly, or no, I guess we have, last part. Would it be reasonable to use the least squares regression line to predict the miles per gallon of a hybrid gas and electric car? Why or why not? Well, let's go back to the data that was used to develop the model. The data that was used was gas-powered cars. So all the cars that were used to develop this linear regression model were gas-powered. Do we think that this would really apply to hybrid cars? We would expect hybrid cars to have quite a bit higher gas mileage than a standard gas-powered car. So this model would not be different. This model would not be appropriate. We don't even need to worry about checking the critical value. It's not appropriate because the type of car, the type of data that was used. So we're going to go with part D. No, because the hybrid is a different type of car. That's it. That's how you do number 8. If you have any questions, let me know.